Hello fellow mathematicians and welcome to Blu-ray Maths. So today we are going to solve this problem. So let's read the problem aloud. Consider 5 points A, B, C, D and E such that ABCD is a parallelogram that is already drawn out there. Inside the circle you can see ABCD and a cyclic quadrilateral is also drawn. Let L be a line passing through A. Suppose that L intersects the interior of the segment DC at F, that is also done, and intersects line BC at G, that is done by extending BC line and AF line. Suppose also that EF is equal to EG is equal to EC, that we have to take into consideration. Prove that L is the bisector of angle DAB. So to prove that L is the bisector of angle DAB, we have to prove that angle DAG is equal to angle BAG. So to prove that, we need to do some consideration as well. Now first of all, you have to know about alternate angles. So can you see the pattern? Angle GAD is equal to angle AGB, this angle. So GAD angle must be equal to AGB angle, that is due to alternate angle, right? And GFC angle is equal to AFD angle due to vertical opposite. Now if this angle is equal to this angle, then AFD angle will be equal to FAB angle, right? So FAB angle will be equal to AFD angle. Then this angle comes, right? Now to prove that angle CFG is equal to angle FCG, you have to prove first that FC is equal to GC, right? So if you prove FC is equal to GC, you are done with this problem. So prove that FC is equal to CG, right? So now let's go through the proof process. Now I'm talking about the substitution that I have done in EDC angle and in angle ECD and in angle GCE. That is just a random substitution that I have done, and you will come across Y in a small amount of time. So now I've done that substitution. After doing the substitution, let's see what we have to do. We have to construct EF line because the question has said that the EF line is also equal to EG is equal to EC. So let's draw an EF line. So now let's notice a pattern. Let's see triangle AGB and triangle FGC. They both are congruent, right? And AB is equal to DC according to parallelogram law. Opposite sides of parallelograms are equal. So that means AB is equal to DC, right? So when AB is equal to DC, if we can find DC, right? So we have to find FC, right? So FC line lies in DC line. That means if we can find DC, then some congruent formulas we can find out the value of FC and CG, and we can just find some relation between them. So yeah, we are going to do that. First of all, what we are going to do is we are going to create a perpendicular bisector from E to FC so that the line from E to FC cuts the line FC into two equal halves. And the same with CG. From E to CG we create a line that cuts CG into two equal halves. This is it. From E to FC and from E to GC, that means we create a perpendicular line. And this perpendicular line, and in this perpendicular line we need CF, right? So in triangle FEC, look at the triangle FEC. Can we say that cos beta is equal to base by hypotenuse, right? What is the base? Base is CF by 2 because base is KC, right? So KC is equal to CF by 2 because it is the perpendicular bisector, so it cuts the line into two equal halves. So it's the same with CGE as well. It cuts the CG line into two equal halves, so CG by 2 by CE, where CE is the hypotenuse. Now just rearranging the stuff, you'll get 2CE cos beta is equal to FC and 2CE cos gamma is equal to GC. Now let's go further. Now let's take a look at triangle DEC. So in triangle DEC, if we can find DC, and GB, we can use the rule of congruency, which you'll see in a few minutes, to be used, right? So to find DC, you can simply use a simple concept called the law of sines. So to use the law of sines, what you can say is that CE by sine alpha is equal to DC by 180 minus alpha minus beta, and 180 minus alpha plus beta will give you sine alpha plus beta. So what I'm talking about is this. Use the sine law, DC by sine 180 minus alpha minus beta, where this can also be written as CE by sine alpha, that's the same, is equal to DC by sine 180 minus alpha plus beta. That can also be written as sine alpha plus beta, right? Because sine 180 minus theta is equal to sine theta, right? So now let's see another way to find the relation of gamma, because over here ECG, in this triangle we only have gamma. We cannot use sine law, but can we do any construction that can help us to use sine law? And the answer is yes, we can use construct BE. So if we construct BE, let's construct it, right? At first let's construct it. Let's construct BE. And what do we know about arc? Look at these two triangles, BEC and EDC. They both lie on the same arc. Means angle EDC must be equal to angle EBC. That means angle EBC must also be equal to alpha. And as EC is equal to EG as said by the equation, we have EGC is also equal to gamma in this way. In triangle EGB and in triangle EDC, angle EBC is equal to angle EDC that I have said lies on the same arc, and angle EBC is equal to alpha if they are equal, right? When they are equal, as EG is equal to EC by the equation, so angle EGC will also be equal to gamma. Now this is done. Now we can use the sine law easily. With the help of this construction, we can use the sine law. Now let's use the sine law. Now what I'll do is I'll say CE by sine alpha is equal to GB by 180 minus gamma minus alpha in this way, which is equal to 180 minus bracket gamma plus alpha, that is equal to the same thing, sine 180 minus theta, that is sine theta, alpha plus gamma. So this is also one formula that we need to solve this problem, to prove that CG is equal to FC. Now next, look at the triangle that I've said, AGB and FGC. They both are congruent, means we can use the concept of congruency to solve this question. Now what we know about congruency, AB is equal to DC, we know that, right? We know in the left hand side you can see AB by FC is equal to GB by GC is equal to AG by FG. That is the congruency rule. Now let's bring the first term that we derived of cos, FC and GC, and look at the left hand side equation, this one. Look at this. Can you like recreate this equation? Can you say GC by FC is equal to GB by AB? Yes, of course, because they both are equal, right? So GC by FC gives you what? It gives you cos gamma by cos beta from that equation, from the blue highlighted equation. Cos gamma by cos beta. Now you can say that therefore GC by FC is equal to cos gamma by cos beta. That is one more important equation that you need. And after that, what you can say is that as over here, CE by sine alpha is equal to CE by sine alpha. In the right hand side as well, there is CE by sine alpha. In the left hand side as well, there is CE by sine alpha. That means you can say DC by sine alpha plus beta is equal to GP by sine alpha plus gamma in this way. And just formulate in this way. GC by FC is equal to GB by AB. So AB is equal to DC. So that's for sure. And you can get the equation like this. GB by DC is equal to sine alpha plus gamma by sine alpha plus beta. So it's some algebraic terms that you need to remember. There's nothing more concrete right now. It's rather easy. Now, what you can do is you can use this equation, GC by FC is equal to GB by AB, and you can equate these two equations. Now it's out of the hell. Now this equation can be solved pretty easily. Now let's see how. This can be crisscrossed, and we can get that equation in front of you, cos gamma times sine alpha plus beta. And there is a little bit a huge equation that looks a little bit scary, but when you simplify it, it gives you the same term as above. So the equation gives this. So when you solve this equation, you'll get this term, and when you solve this equation, you'll get cos beta term. When you solve this equation, you'll get cos alpha term, and that's it. After that, just cancel each other out and solve for sine and alpha plus beta minus gamma. Solve this equation, you'll get beta is equal to gamma. So as beta is equal to gamma, CF is equal to FC. That's proved, right? Because if beta is equal to gamma, then beta is equal to beta, right? If beta is equal to beta, then here at EGC as well, there must be beta. Means this angle will be equal to angle FEC must be equal to angle GEC by this law. Beta is equal to gamma, right? Therefore, this GC is equal to FC. Therefore, hence proved that this line passing from AG is a perpendicular is a angular bisector. Sorry, it's an angular bisector of angle DAC. And yeah, according to isosceles triangle. And thank you for watching. Goodbye and have a great day.